Welcome everyone. In today's video, we are going to explore the rules that govern quantum entanglement. You know, quantum entanglement, this is a most famous phenomenon in the field of quantum mechanics. Okay, strange phenomenon actually. And in this connection, there is a famous saying of Albert Einstein. He called it spooky action at a distance. You know, in any quantum system, if particles remain entangled, then that entanglement obeys three rules of quantum physics or quantum mechanics. Three rules are there. And whenever we talk about entanglement, quantum entanglement, that means only two particles are involved, not like that. More than two particles may also remain involved or may also remain entangled simultaneously, more than two. Okay, but here in this video, we are talking about only two particles, okay, to make the explanation easier for you. Say, as a particle in the quantum system, we are choosing electron, and you know electrons have two spins, up spin and down spin. So we say there are two electrons in a quantum system, only two electrons are there, and they are entangled. Okay, so what is the rule number one? According to rule number one says what? Rule number says that they must obey the principle of superposition. So I was talking about only two states. Each of them can be either in up spin state or in down spin state. So when they are in superposition, when they are entangled, then in that case they are in superposition. That means each electron's state is a combination of both the states simultaneously, both the up and down. It is a combination of all possible states. Generalized statement is what? In case of superposition, that should be a combination of all possible states. So here in case of electron, we are talking about only two states are there. Possible states are two. Number of possible states are two, up and down. So that is a principle of superposition. Okay. So entangled particles must obey principle of superposition. That is rule number one. Rule number two is what? Entangled particles correlate instantaneously. Entangled particles correlate instantaneously. So again, let's come back to the example of electrons. Say two electrons are there and distance between them is say 1 million light year. Such a vast distance, okay. And they are entangled. No doubt they are entangled. We are talking about quantum entanglement. So both the electrons are entangled. So if you change the state of any one electron, immediately that affects the change in the state of the other. Means if you measure the state of any one electron, then there will be a corresponding change in the state of the other. So if we talk about electrons up and down, two states are there. Say you are measuring the state of one electron and you have got up. That means immediately it determines the state of the other. The other state will be down, not up. If it is up, if one is up, the another one must be down. And that is also governed by rule number 3. One rule is there to govern that thing. Rule number 3 is what? Rule number 3 is they must obey the conservation principle. So we were talking about spins. So total spin must remain conserved. Total spin means up spin and down spin. If both are up spins, then that is not obeying the conservation laws. If both they are downspins, then also conservation laws are not followed. So to preserve the conservation law means to maintain the conservation law. Better to say to maintain the conservation law, if one is up, another one must be down. If one is down, another one must be up. And that's why it is possible when you are measuring the state of one particle and you know the state of that particle. Suppose in the case of electron you have got the state of the particle to be down, then that means without measuring the other one, you can confidently say that the other one is in a state of up. So this is what? This is from, this we are getting from conservation law. Okay, this we are getting from conservation law. So there are total of 3 rules which govern the principle of quantum entanglement. And what was rule number 2? Rule number 2 was they correlate instantaneously. And after observing this phenomenon in quantum mechanics, Einstein said that thing, spooky action at a distance. That does not mean that faster than light communication is becoming possible in that case. No. Actually, in that case, I am talking about right now rule number 2. In that case, you can say that they are working as a pre-agreed system. What is the meaning of that pre-agreed system? That means they know what to do when any one of them is measured. They know what to do when any one of them is measured. And that's why you are getting that instantaneous result. Though the actual reason behind this is still not known to the scientists. Result is known. What happens, that is known. But why this is happening, how this is happening, that is not known. Why this is happening, you can say, oh, they are entangled, that's why this is happening. But how? That is not known to anybody at present. Okay. Rules are known, but the cause behind the rules are not known. So this phenomenon is quite strange. And if you study quantum mechanics, you will get many more strange phenomena. That is known to you if you have already studied to some extent quantum mechanics. Anyway, and using this principle, you know, technologies are being developed like quantum computing systems, quantum cryptography. So applications are there. Okay. And in the near future, we are going to be more dependent on these principles. And scientists are trying to harness many more things from the field of quantum mechanics to use in technologies, to develop new technologies. From lasers to medical imaging, everywhere you can see the use of quantum mechanics or quantum physics. That means you can see the use of quantum superposition, quantum entanglement, etc. Okay. Anyway, scientists are expecting drastic changes in the near future by the help of these technologies. Anyway, so I was actually talking about only the 3 rules that govern the quantum entanglement. Only 3 rules. Okay. Superposition, instantaneous correlation, and conservation. Only 3 rules are there. Okay. Okay, so this was all about today's video. This is the end of this video. Thank you. Thank you for watching this video.